Hi, it's time for another math easy solution. Turn to discuss further into trigonometric integrals and look at example 2 of the example series and solve this seemingly complex example, which is sine to the power of 5 of x times by cosine squared of x dx. Now, when dealing with integrals like this, like I showed in my earlier video, basically if you recall from my last video, that when dealing with trig powers, it is best to write integral with one cosine or sine term, and the rest either sine or cos terms. For example, you would want to write something like sine of x with no power, or just power of 1, and then the rest are going to be, for example, cos power of 5 plus cos squared x, etc., etc., something like that. Or if you had the one cos term, and then the rest will be sine terms, so something like that, and this is all sine, etc., so something like this. And once again, the reason for this is then we would use substitution rule, and we would take it for one of these terms, either the cos x or in this case sine, and then the differential will get a cos term and a dx, so we'll cancel that out. I'll get to that in a bit. Yeah, so in this example we could convert this cos squared of x using the trig identity. This can be 1 minus sine squared of x, but now we'll have everything's going to be just sine of x. Yeah, and we'll have no cosine term. So in this case, instead we could separate a single sine term. Yeah, and the way to do that is a pretty clever trick. So we would write this integral sine power 5 of x cos squared of x dx. Now this would equal to, what we could write this, because it's an odd power, we could just take a sine out of there. So sine of x, and now we'll have inside, we'll have a sine to the power of 4, which is also the same thing as writing sine squared of x and then all squared, just so we're dealing with something we're familiar with. That's over here. So now, and then times it by cos squared x dx. And now, so now we have one sine term. Now we could write everything else in terms of cos by converting this sine squared of x into terms of cos. So this would equal to integral from sine of x times it by 1 minus cos squared of x all squared times by cos squared of x dx. And now that we have our sine, one sine term, the rest cos terms, now we could apply the substitution. So we can let u equals to cos of x, and the reason for this is because when we get the differential, du is going to be negative sine of x dx. And in this case, yeah, we'll have sine x dx equals to negative du, and then this gets rid of this function, yeah, and this dx becomes du. So then we could write this whole thing out. So integral of sine 5x cos squared of x equals to integral of, so now this sine of x dx is gone, but we put a negative sign, it's negative du. This is going to be 1 minus u squared, and now we have a u squared du. So we've written it, we've basically removed all of the trig functions now using the substitution. Now we could expand this out. So negative, this one, multiply this out. This would be 1 times 1, that's just going to be 1. 1 times u squared, that's u squared, and then u squared, negative u squared times 1. Again, you'll have a second term, so just add those up. And now we have a plus negative u squared times u squared, that's just u to the power of 4. Now we have a u squared du. Now we multiply this inside, so we'll have a negative, and then this is going to be u squared minus 2u4 plus u6 du. Now we can apply the integral. So this just equals to negative and an integral in this one is just going to be, well, u3 over 3 times it minus u to the 5, there's a 2 there, divided by 5, plus now u7 divided by 7, and we always have to add the constant. So now, and then we just put the negative inside, so negative 1 over 3 u to the power of 3 minus minus 2 to the 5, this is plus, because the negative becomes plus, u5, and then there's a minus u, or 1 over 7, u7 plus c, and now we could just add our cos of x. So we have our u is this right here. So adding that, we get 1 over 3 cos power of 3 of x plus 2 over 5 cos of x power of 5. Put this like that. Minus 1 over 7 cos 7 of x plus c. And now there is our answer. Yeah, now if you were to graph the two functions, this is inside the integral or the integrand, and this is the integral where in this case we have c equals to 0, or the constant equals to 0. I just want to graph it just to show, and it could serve as a double check, because we know that the integral is the antiderivative of the inside function, and in this case it's sine 5 cos squared. And as you can see from here, so this one here, so basically you can consider the integrand or the inside function as the derivative, or d of dx of f of x, and then you can consider this as f of x, and this equals to the integral of the function that we were just doing, dx. And as you can see, whenever this is flat lines it here, or the slope is 0, slope equals to 0, and that is basically the derivative. It's when it's 0. So at every single time when this is 0, or when this is flat, there is the derivative 0, and at the highest point of the derivative is to correspond to the biggest slope. And then also it's here 0 when this is 0 again. So basically you can see from the graph that this answer seems to be right. Anyways, that's all for today. Hope you learned from this pretty extensive example, and like always, you can download these exact notes in the link below. Thanks for watching, and stay tuned for another Math Easy solution.